So what I've done, I ran this npm test command, and we see the stack come alive. So we've got ident, Alice ident, NAT streaming, a service called InChain, a couple of consumers, which are NAT streaming consumers, the Nethermind client for Alice, Postgres, provide NATs, which is a fork of the NAT server that provides decentralized bearer token authorization. This is an enterprise-grade authentication service that vends these tokens, or rather an enterprise-grade authentication and authorization service called ident vends these tokens, which then provide explicit access to specific subjects. For example, Bob authorizes specific set of subjects that Alice and signs the token and then delivers it to Alice when he invites her to this baseline work group. Alice gets a stats daemon, which is basically a service of InChain that does analytics, basically subscribes to various blockchain, various networks that Alice in this case is interested in. The stack provides Redis for caching key value pairs that are accessed frequently. The Vault instance, and then you see Bob's stack start to spin up as well. And then you see like a bunch of logging happening. And then what we're starting over here is the creation of Bob's creation of the work group, essentially in his local ident service. Ident is the local service that implements the iRegistry interface for the baseline API, the baseline spec. You see some assertions about how Bob has, the work group, Bob's work group that he just created has a bearer token that's authorized for it. It's similarly to what I was mentioning regarding that and how that works. And then a few assertions about how the ERC 1820 registry contract and ERC 1820 org registry contract have been deployed for the work group. And you see like the initiator, which is Bob in this case. You see that he, his configuration is same for the instance that was initial, for his participant stack. It basically asserts that he is the initiator, which means that he is, when that's true, his instance will be responsible for automatically deploying the workgroup contracts. For example, the reason this happened is because Bob was the initiator. Bob is also, as the initiator, is also, it's not required, but likely responsible for setting up the first workflow, meaning the first zero-knowledge circuits that are required for the workgroup to be productive in the baseline context. So we do make some assertions around how there's some output from Socrates there. We're using a very basic no-op circuit. Basically, some assertions are made about how a unique identifier was generated by our privacy by the baseline privacy package. Every new setup every trusted setup that's run in that service gets a unique UID assigned to it. Improving and verification keys for the zero knowledge for the ZK SNARK circuit. Basically, the Socrates is outputting these keys in memory. Nothing's being written to disk in this case. It asserts that the raw verifier contract's solidity source code was generated properly. It also asserts that the workflow circuit identifier stored on Bob's participant stack. It also asserts that the workgroup shield contract was deployed and that that workgroup shield contract was tracked. The verifier contract that was generated during the trusted setup step is also deployed to the blockchain. In this case, we're talking about Ropsten. We can take a look at Ropsten. So if you take a look at Ropsten, you see a couple of minutes ago, we had this transaction. Pop up over here. There we go. So in Ropsten, you see we have this transaction. We subsidize the transaction for the deployment. Deploy the contract, which deployed some contracts. Essentially, the Workgroup org registry contract was deployed, and then we made some assertions. We made some assertions around the Bob's or like Workgroups. So the Bob's participant stack had a local reference to the ERC 1820 registry contract, the org registry contract, the Shield contract. That the Shield contract had been tracked in the off-chain Merkle tree database. This is actually a very awesome feature. Huge shout out to Tomasz and his team in Nethermind for just going above and beyond for this release to deliver that this functionality. I think we'll be doing a sort of a focus segment with Tomasz very soon to dig into that. Very good stuff. We're asserting that the workflow circuit, that Bob's organization has a reference to the workflow verifier, and that the identifier is also cached. We're asserting that a NATS connection has been established. We're asserting that Bob's participant stack, successfully connected to NATS and established a listener or a message handler for asynchronous handling of the baseline.inbound NAT subject, which essentially allows for any authorized anyone who's been authorized against using a bearer token signed by Bob can connect to Bob, and as long as Bob has granted permission on the baseline for those connecting entities to publish messages on baseline.inbound, Bob will receive those messages. They are protocol messages, baseline protocol messages that are handled by Bob on his end. It's asserted that Bob's organization is asserted in the local registry. It's asserted that the on-chain registry, Bob's received a K1 key pair. Basically, vaults is used. The vault service that is part of the provide stack and part of the iVault interface with the baseline protocol. That iVault interface is used to generate a K1 key pairs of Ethereum public, Ethereum address. The address representation, the Ethereum public address representation of that K1 key pair is used sort of like a primary key if you think of a traditional relational database. And that's used to look up the organization on the blockchain. Interestingly, that K1 address, that public Ethereum address, is never used to sign any transactions, and that's another interesting functionality or feature that our vault, the provide vault service, supports is the ability to restrict signing. So, like, you can you can be certain that you're not leaking sensitive information to the blockchain because of the way the vault service protects you from yourself, essentially. Essentially that address is never used to sign a transaction, that key rather. And then HT wallet is subsequently generated for each organization, that uses the vault. And those HT wallets never allow a single, one account within no hierarchical deterministic key derivation path is ever used to sign two transactions. It can only be used to sign one transaction. And that again creates more guaranteed anonymity, and it's harder to if no address ever signs more than one transaction, it's much safer in the context of a work group, much safer in the context of the public blockchain. It's not that's a good feature. The organization is associated with the local work group, and then here's the assertions around the vault. Created a default vault for Bob. It created a default set of key pairs for Bob. It created an elliptic curve, a baby jib-jib elliptic curve key pair for Bob. It's used for it's a special curve that's used for the privacy protocols. The K1 key pair was generated, and basically you can use that key pair then to resolve the organization's on-chain identity. So that's where that 50 milliseconds comes in. This actually hit the public blockchain just to verify, hey, that organization is in their org registry contract, and the key that we expect it to be keyed against, like that primary key that I mentioned, using the primary key loosely there. It is keyed against that primary key, and then sort of the big one, the most important one, the one that's going to do all the heavy lifting here, is the BIP HT wallet that, like I mentioned there just moments ago, will only let you sign a transaction with a derivation path once, or one transaction per derivation path signed. Awesome. So then we start to talk about Alice, and we assert that, hey, Alice was invited to the work group. Alice then accepts the invite, and a bunch of similar, well, this is the invited context. So we assert that Alice is, has the same config like this, similarly how we did Bob, except we assert that Alice is not the initiator of the work group. That's just for some sanity around the test suite. We verify the we make sure that the work group, that Alice got a copy from Bob when she pulled down the data about the work group from Bob, and Bob invited her. Alice was like, yeah, I'll accept the invite. She used the decoded bearer JWT that Bob sent her as part of the invite process to look up Bob, to look up the work group, and to pull down data from Bob directly, because Bob also included that assigned JWT in the invite for Alice, so Alice could directly look Bob's messaging endpoint up on the public blockchain and connect directly using assigned bearer authorization token vended by the IDENT service. Yeah, so similarly, we're going to make some assertions that Alice, when she pulled the data down, she got a same copy of all the same contracts that Bob got. The ERC 1820 registry contract, the on-chain organization registry contract, the workgroup shield contract, the off-chain Merkle tree database got tracked, that the shield got tracked, and then there's the local reference to the verifier, the workflow verifier, and that the workflow circuit identifier was also cached. Similarly, again, we're going to establish, was Alice able to subscribe to baseline.inbound protocol messages? Seems like she was. Was Alice registered in her local org registry? Was she registered in the on-chain? Was Alice added to the org registry contract on-chain? Was she associated with the local work group? Alice's vault got all the same treatment that Bob's did. And then here we make some additional assertions about counterparties here, which is really a nice addition, where we're talking about how each like Bob has a local reference to Alice, and Alice has a local reference to Bob, and they can both talk over the baseline protocol. And you see this initial proof generation work step. That actually, and we see this log message, and we see some like the TXRX counts are being asserted here. We might put in a couple of more tests into the suite, but all in all, this is about as far as we were able to get for the v0.1 release. I'm not disappointed in the result.